In a previous video, I spoke a little bit about perfect cubes. And a perfect cube looks a little bit like this: a plus b in brackets cubed. And I showed you how to expand that out really quickly. In this video, I'm going to be talking about the sum of cubes. Now, the sum of cubes is where you've got a cube, a cubed. And the sum means there's a plus, you're adding those two cubes together. So I've got b cubed and a cubed, and I'm adding them together. So the sum of two cubes. Now, it's very important to note that the sum of cubes is not the same as a perfect cube. This is a perfect cube. And this is the sum of cubes. Sum of two cubes. And I can also have the difference of two cubes. So a cubed plus, minus, difference means minus, a cubed minus b cubed. So this is called the difference of two cubes. Difference of two cubes. And so we have three different types. Now, remembering that with a perfect cube, I also had a minus b in brackets cube. Now they both, that there means a perfect cube, and that there also means a perfect cube. And I went through in the last video and showed you how to expand those. With the sum of cubes and the difference of cubes, it's not expanding, but it's factorizing. So we're actually going from the expanded form to the factorized form. So I'm going to do that now. So with the sum of cubes, if I was to start with a plus b in brackets multiplied by a squared multiplied by a times b plus b squared, and I was to expand this out, so I was to say a times a squared gives me a cubed, a times negative ab gives me minus a squared b, a times b squared gives me a times b squared, and then I was to multiply the next three. B times a squared would be a squared times by b times by negative ab would be minus a times b squared, and b times b squared would be b cubed. And if I was to collect the like terms for this, I'd end up with negative a squared b and plus a squared b. Well, they cancel each other out, and I end up with plus ab squared and minus ab squared. Well, they cancel each other out, and all I'm left with is a cubed plus b cubed. So a cubed plus b cubed. So what that's saying is that if I started with this form here, the expanded form of my cube, a cubed plus b cubed, then I could actually quickly go straight from this form into the factorized form, which is a plus b multiplied by a squared subtract ab plus b squared. And likewise, I could do the same thing for a cubed minus b cubed, but rather than having a plus here and a minus sign here, I have a minus sign here and a plus here. So an example for that would be x cubed minus 1000 y cubed. Then the first thing I want to do is convert everything into cubic form. So I would make it x cubed minus 10 cubed multiplied by y cubed. And so 1000 is equal to 10 cubed, and so then I can convert it to be like that. And then what I can do is to get my a and my b, I've already got my a here, which is just x, but to get my b, I could then go, well, x cubed minus, and because a to the power of b multiplied by c to the power of b, it can actually become ac in brackets to the power of b. Using that power formula, I can convert this to become 10y in brackets to the power of 3. And so x and 10y are my a and my b. And then I can actually go and factorize it. So if I've got my formula here of a cubed minus b cubed, which is equal to a minus b multiplied by a squared plus ab plus b squared, then this over here would become x minus 10y multiplied by x squared plus x multiplied by 10y plus 10y in brackets squared. So then I could finish off by going, well, it's x minus 10y in brackets x squared plus 10xy plus 10 squared is 100 and y squared is just y squared. So that there would be my factored form of this example here. For my second example, well, I have 2 multiplied by x plus 6 in brackets cubed plus 16. I can first of all factorize the 2. So this is a term here, okay, and this is also a term, and there's the sum. So we've got the sum of two terms, and what I can do is I can factorize a 2 out of both this term and this term. So that's what I can do. So 2 in brackets is pulled out of this term, so I'm pulling this out of this term, and so I'm left with x in brackets, x plus 6 in brackets cubed, plus I can pull a 2 out of this term, so it becomes plus 8 in brackets. And then I have 8. Well, 8 is 2 cubed, so I can make this become 2 in brackets x plus 6 cubed plus 2 cubed, and then I have my a and my b. My a is the x plus 6, my b is the 2. So if I was to go and expand that out using the formula of a cubed plus b cubed equals a minus b in brackets, sorry, a plus b in brackets a squared minus b times a, or a times b, plus b squared. Using that formula, I can say that I would end up with 2 multiplied by x plus 6 plus 2 in brackets multiplied by x plus 6 in brackets squared minus 2 multiplied by x plus 6 plus 2 squared in brackets. Now, when I'll clean this up a bit, it would actually then look like 2 in square brackets, and then x plus 8 in brackets multiplied by x squared plus 12x plus 36, subtract 2x and subtract 12, and plus 4. And then cleaning this up, finally, it would actually look like 2 in brackets x plus 8 multiplied by x squared, and collecting like terms, it becomes 12x minus 2x is plus 10x, and 36 minus 12 is 24, plus 4 is 28. So I put 28, and that there would be the final factored form from this cube over here.